polymer composition. Most polymers are hydrocarbons, right? So among this said wood, cotton, leather, rubber, wool, silk, usually most of the polymers are hydrocarbons. So what are hydrocarbons are? That will have hydrogen and that will have carbon, right? That will have hydrogen and that will have carbon. So if you take any polymer, the most of the composition will be carbon and hydrogen. So if you want to make it as a kind of percentage, right? So say for example, you have PVC, polyvinyl chloride. So in that you have chlorine, hydrogen, carbon, and chlorine. Right? So if you want to separate it based on percentage, right? Then you will find that is chlorine would be of around 20%, but the hydrogen and carbon is the 80%, right? So that's what it said. Most polymers are hydrocarbons. H and C would be the major constituents in a polymer, in a composition, right? In a polymer composition. There can be others also, chlorine, fluorine, oxygen, H. So these all will be there, can be there, but only this H and C form the major part of this constituent, right? Then we come to saturated hydrocarbons, right? So now you need to recall the valence number of the carbon. Periodic table, carbon is coming in 4th tiers, right? Hydrogen, HHG, here lithium, first one, beryllium, second one, boron, third one, and carbon, fourth one. Then you have nitrogen, oxygen, these all will be there. My concern is only about carbon now, right? So this is first group, second group, third group, and fourth group. So carbon is in fourth group, right? Nitrogen, oxygen, fluorine, and neon will be there. That's fine. We are not going to go to that neon part now, right? We will stop only with the carbon. So now the valency of carbon is 4, right? You know that, which means it can form only 4 bonds, right? Carbon can form only 4 bonds since it is in the fourth group, 1, 2, 3, and 4. Right? Since it's in the fourth group, valency is 4, which means it can form only 4 bonds, right? Now we will take this carbon, right? So this carbon has 1, 2, 3, and 4 bonds, right? So now this carbon has 4 bonds. If I take about this carbon, this has 1, 2, 3, and 4 bonds. All right, this has 4 bonds. I told you carbon can form maximum of only 4 bonds, right? So saturated hydrocarbon means each carbon bonded to 4 other atoms, right? It is bonded to 4 other atoms. All right. So here with this hydrocarbon, one is bonded with hydrogen, the other one is also bonded with hydrogen, third one is also bonded with hydrogen, the fourth one is bonded with the carbon, right? Similar way, if you take this carbon, first one is bonded with that hydrogen, this one is bonded with this hydrogen, this one is bonded with this hydrogen, and here is bonded with the carbon. So there are 1, 2, 3, and 4 bonds. If I take this carbon, 1, 2, 3, and 4 bonds, right? So if each carbon atom bonded to 4 other atoms, which is said as saturated hydrocarbon, which means it's full. We can't introduce any more bonds, right? We can't introduce any more bonds. So 4 other atoms are the important part here, right? If it is bonded with 4 atoms, we can't add more bonds. So this is given by the formula CnH2n plus 2, right? Saturated hydrocarbons can be given in the formula CnH2n plus 2, right? So say for example, I will put n is equal to 1, right? I'll put n is equal to 1. Cn, C into Cn, so that is 1C H 2n plus 2. So I need to put 1. So 2 into 1, 2 plus 2, that is 4, right? That is 4. So that will be giving you CH4, that is known as methane, right? You know that CH4 is known as methane. Okay, I will put n is equal to 2. All right, I will put n is equal to 2. In that case, I will replace this n with 2, C2, right? C2H. I will put this 2 here. So 2 into 2, 4, plus 2, 6, right? C2H6. C2H6. This is known as ethane, right? This is known as ethane. In the similar way, if you put n is equal to 3, if you put n is equal to 3, so C3 n is equal to 3, H, that is 2 into 3 plus 2, that is H8, right? So C3H8 is called as propane. Right? Similarly, you can keep on increasing the number of n and replacing with this formula. You will be getting different composites, right? So if you put 4, you will get C4H10, that is known as butane. Then if you put 5, you will be getting C5H12, that is pentane. Like that, it will be keep on increasing, right? So if the all bonds are bonded with other 4 atoms, it is called as saturated hydrocarbons, right? So we should have 4 atoms around a particular carbon atom, then that is saturated hydrocarbon. This is just like after replacing with these numbers. So CH4 is methane. This is the structure, and the boiling point is also given minus 184 degrees Celsius, right? Then ethane C2H4, sorry, C2H6. This is the structure C2 1 2 3 4 5 6, and boiling point is 88 minus 88. Sorry. Propane I have C3H8 1 2 3 1 2 3 4 5 6 7 8, right? So that will boil at 42 minus 42 degrees Celsius. Then I have butane C4H10, right? Due to lack of space, it will be drawn, and this boiling point is minus 0.5. Pentane C5H12 36.1 plus. Hexane C6H14, that is 69 degrees Celsius. So this will keep on going, right? So the naming is probably based on the available, I think, Latino no Roman system. So meth, ETH mean 2, prop mean 3, but mean 4, pent mean 5. Pentagon, you remember? Pentagon, pent mean 5. Hexagon, 6, so hex means 6. Heptagon, HEPT, that is 7, right? HEPT, hexane is 7. Then I have OCT, octane, that is 8. Then it's nonane, that is 9. Decane, 10. So this will keep on going, right? So when you increase the number of carbons, automatically this H will also increase based on that formula, CnH2n plus 2, right? So accordingly, boiling point will also increase with the increase of the number of carbons, right? With the increase of the number of carbons, boiling point will also, if you see, increasing.